Good morning. My name is Tomotaka Kobayashi, and I'm a master's student from Waseda University. Oh, thank you. Thank you. The title of this presentation is Quasi-stability Theory with Multidimensional Taylor Expansion, revealing transmutation of atoms in cold fusion phenomena. At first, let us consider about the symbiosis of symmetric and asymmetric ratios in natural phenomena. Symmetric ratio 1:1 and asymmetric ratio about 2:3, like golden ratio, Symbol ratio, and Yamato ratio are often seen in nature, which is constructed with various sizes of particles. It is known that symmetric ratio 1:1 and asymmetric ratio about 2:3 are seen in fission of uranium-235. And it is also known that symmetric ratio 1:1 and asymmetric ratio about 2:3 are seen in division of yeast cells. Now, I'd like to explain the reason why the specific ratios appear in natural phenomena. To put it simply, these phenomena are breaking up of flexible particles interacting. Random atoms and yeast cells can be assumed as flexible particles because they are deformed while they are splitting. Assuming breaking up of flexible particles interacting, fluid dynamics can clarify why symmetric ratio and asymmetric ratios are observed in particles in nature. Also, Niels Bohr thought by using energy conservation, momentum conservation of fluid dynamics will reveal details because three-dimensional space can be considered. There are 5 assumptions to describe deformation of connected flexible particles. First, particles have flexible axis-symmetric spheral shapes with deformation rate of gamma equal A per B, while A and B are ready for the spheroid particles deformed in time. When gamma equal 1, the particles are assumed as sphere. Second, unified form for various surface forces coming from nuclear force, Coulomb force, surface tension, and gravity as a form of 1 per r to the power of m, while r and m denote the local curvature of particle surface and a constant, respectively. M equal 1 implies that the fluid dynamical surface tension. Third, the potential flow is assumed for convection inside the particles generated by high impact speeds of other particles surrounding particles connected. And fourth, inline connection of 2 particles having the size ratio epsilon is considered. Epsilon equal 1 means symmetric connection to 2 identical particles. And fifth, contact surface position between two flexible particles connected is also a little indeterminate in biological and subatomic phenomena because stochastic effect should be added to continuum mechanics. From these assumptions, the momentum equation of connected flexible particles is derived in previous reports. This is a momentum equation of connected flexible particles with particle deformation rate gamma, a size ratio of particles epsilon, constant of surface force m, indeterminacy of the contact position delta m, and a random fluctuation delta. This gamma epsilon m equation is derived based on statistical fluid dynamics, including convection based on potential flow, assumption and then extended formulation of contact surface for surface tension. The first order of the Taylor approximation equations of gamma epsilon m equation can explain the appearance of the size ratios 1 to 1 and about 2 to 3 in natural phenomena. If the size ratios of two particles is 1 to 1 or about 2 to 3, one term in the right-hand side of the approximation equation becomes 0. For example, the epsilon equal 1 make this particle this term 0, and epsilon equal 1.44 is about 2 to 3 makes this term become 0. From these things, quasi-stability is defined. Quasi-stability is defined as mathematical condition that only one part for or one term of equation system becomes 0. This stability concept is weakest stability between neutral stability and unstable conditions. However, this weakest stability is important to explain natural phenomena because the atoms and biological systems often have lifetimes. In previous report, quasi-stability analysis based on the one-dimensional Taylor expansion is conducted. Quasi-stability analysis using one-dimensional Taylor expansion qualitatively revealed specific ratios appearing in natural phenomena in wide range of scale, including cold fusion. According to this figure, the ratios revealed by quasi-stability theory based on one-dimensional Taylor expansion lead qualitative agreement to actual mass ratios seen in cold fusion phenomenon. In this report at ASSISI, we use multidimensional Taylor expansion for quasi-stability theory instead of one-dimensional Taylor expansion to lead quantitative analysis of the size ratios seen in cold fusion phenomenon. Multidimensional Taylor expansion is a type of Taylor expansion which is used for equations having two or more variables. This is a theorem of multidimensional Taylor expansion for two variables. Product terms of two variables appear in multidimensional Taylor approximation equation. Such terms do not appear in one-dimensional Taylor approximation equation. Quasi-stability theory based on multidimensional Taylor expansion leads new size ratios leading quasi-stable condition, which are not revealed by that of one-dimensional Taylor expansion. This is a second-order terms of multidimensional Taylor approximation equation. These terms include all terms in those of one-dimensional Taylor approximation equation, which are shown in blue area, and new terms which are shown in green area. Non-size ratios, for example, 1.44 and 1.35, make one term in blue area become 0. And on the other hand, new size ratios, for example, 1.41 and 1.88, make one term in green area become 0. Now, I'll show you some results of quasi-stability analysis. Quasi-stability analysis based on multidimensional Taylor expansion leads qualitative agreements to mass ratios of base pairs better than that of one-dimensional Taylor expansion. This figure shows the result of quasi-stability analysis, which are comparison of the ratios derived from quasi-stability theory and actual mass ratios of base pairs. Left-hand side one shows the quasi-stability analysis based on a one-dimensional Taylor expansion, and right-hand side one shows that of multi-dimensional Taylor expansion. The data levels shown in red color, this one, is a better agreement derived by multi-dimensional Taylor expansions. This ratio, 1.19, is closer to actual mass ratios of base pair, 1.21, than known size ratios, 1.27. The quasi-stability analysis based on multi-dimensional Taylor expansion leads qualitative agreement to mass ratios of amino acids better than that of one-dimensional Taylor expansion. This figure shows the comparison of the ratios making quasi-stable conditions derived from quasi-stability theory and actual mass ratios of amino acids. Left-hand side one shows the quasi-stability analysis based on one-dimensional Taylor expansion, and right-hand side one shows that of multi-dimensional Taylor expansion. Data levels shown in these graphs denote the ratios making quasi-stable conditions, which are close to actual mass ratios of amino acids. And the levels shown in red color is better agreement derived from multi-dimensional Taylor expansion. This result shows that quasi-stability analysis based on multi-dimensional Taylor expansion lead better agreements to mass ratios of amino acids than that of one-dimensional Taylor expansion. And the quasi-stability analysis based on multi-dimensional Taylor expansion leads quantitative agreements to yield curve of random fission better than that of one-dimensional Taylor expansion. This graph shows the comparison of distribution of the ratios derived from quasi-stability theory and actual yield curve of random fission. Left-hand side one shows the quasi-stability analysis based on one-dimensional Taylor expansion, and right-hand side one shows that of multi-dimensional Taylor expansion. According to these graphs, quasi-stability analysis based on the multi-dimensional Taylor expansion makes good agreements to actual yield curve of random fission at around 85 and around 145, while that of one-dimensional Taylor expansion do not. This result shows that quasi-stability analysis based on multi-dimensional Taylor expansion lead better agreements to yield curve of random fission than that of one-dimensional Taylor expansion. And this is important. Quasi-stability analysis based on multi-dimensional Taylor expansion leads quantitative agreement to size ratios of production in cold fusion better than that of one-dimensional Taylor expansion. This graph shows a comparison of the ratios derived by quasi-stability theory and actual size ratios of the production in cold fusion phenomenon. Left-hand side one shows that the quasi-stability analysis based on one-dimensional Taylor expansion, and right-hand side one shows that of multi-dimensional Taylor expansion. Data levels shown in red color are better agreements revealed by multi-dimensional Taylor expansion. This result shows that quasi-stability analysis based on multi-dimensional Taylor expansion lead better agreement to size ratios of production in cold fusion than that of one-dimensional Taylor expansion. Now, I'd like to show you the conclusions in this presentation. Quasi-stability theory based on multi-dimensional Taylor expansion leads both known size ratios to make quasi-stable conditions divided by that of one-dimensional Taylor expansion, and new size ratios making quasi-stable conditions which are not revealed by that of one-dimensional Taylor expansion. Quasi-stability analysis based on multidimensional Taylor expansion leads quantitative agreements to actual mass ratios of biological particles, such as base pairs and amino acids, better than that of one-dimensional Taylor expansion. Good agreements to yield curve of Brownian fission, better than that of one-dimensional Taylor expansion, and quantitative agreements to actual size ratios of production in cold fusion are better than that of one-dimensional Taylor expansion. Here is the outlook. Size distribution of production in cold fusion phenomenon might be predicted by using quasi-stability theory based on multidimensional Taylor expansion, like yield curve of Brownian fission shown in this presentation. If quasi-stability theory based on multidimensional Taylor expansion and the other theory written in a previous report, which are presented by Ken Naito in 2017, are used, occurrence conditions of cold fusion might be predicted. And we are going to conduct some fundamental experiment of cold fusion to validate this theory, and in very near future, experiment of weak cold fusion engine assisted by chemical reaction, which are presented by Ms. Konagaya before this presentation, will be conducted. Okay, thank you for your attention.